Okay, so sorry for the delay. We had some technical issues. Okay, so this is the problem. Okay, so yesterday I have given you a problem that is you have to design a corner column which is having a dimension of 400 into 400, which is subjected to a factored loads of PU is equal to 1300 kilonewton. Okay, please note the PU is 1300 kilonewton. Moment along the x direction is 190 and moment along the y direction is 1110. And this is located in the lowermost story of a system of braced frames. Okay, braced frames are and the unsupported length of the column is 3.5 meter. Design the reinforcement in the column. Assume M25 and FE415 steel. Okay, so these many details are given in the question. So you are asked to design a corner column. Okay, or a building in it. There is a multi-story building. For the multi-story building, a corner column you have to design. So just like this. Okay, so you can see in this figure, this is a corner column. Okay, so this corner column, so definitely a corner column, most of the corner column will be subjected to biaxial bending. Okay, you can see a beam that is running over here and another beam is running on the other direction. Okay, so you have to design a corner column like this. The dimension of this column is given as 400 into 400. Okay, the dimension of the column is given, and they also tell that this is located in the lowermost story. Okay, so the building in the lowermost story level is, and the unsupported length is also given. Okay, unsupported length is given, and they also told us this is a system of braced frames. Okay, this is a system of braced frames. So in case of braced frames, you have to take this as that is a braced frame. That will be coming under the case that the one end will be fixed and other end will be hinged. Okay, one end will be fixed and other end will be hinged. Okay, so you have to refer the IS code for that. Okay, refer the IS code. So how the condition will be? The condition will be it will be held in position at both ends. Okay, both ends it will be held in position, and one end, what is it, will be restrained in rotation. Okay, one end it will be restrained in rotation. Okay, that will be the condition. Okay, so based on this condition, you have to find out your respective effective length from the IS code. Okay, table 94. Okay, so that will be second case. Okay, second case, and the L effective will be 0.8 into L. Okay, you can refer the IS 456. Page 94. Okay, page 94 they have given about the effective length. So this is like one end will be fixed and other end will be hinged. Okay, so in that case, what is the condition? Both ends will be held in position and one end will be restrained in rotation. Okay, so that is second condition. Secondly, effective length will be 0.8 into L. Okay, all of you please note that. In case of braced frames, okay, in case of braced frames, L effective will be 0.8 into L. Okay, so this is the condition that is given. Now that you have to design this column for the biaxial bending. Okay, so shall we start? Have you written the question? Have you written the question? Shall we start now? Someone please reply. Shall we reply? Shall we start? Okay. Okay, so this is the condition and this is the column. Okay, this is a column that we are going to decide. This is corner column. Okay. Now coming to the next one. Okay, so this is the case. So first of all, they have not given any condition. So as a previous question, you have seen that they have given the size of the column. Okay, the size of the column is given. Then, they have given they have specially mentioned that this is a short column. Okay, in this case, they have not given any such details. Okay, previously they have mentioned that it is a short column, but here they have not mentioned whether it is a short column or a long column. Nothing they have mentioned. Okay, so we have to start from the top. They have only told you one details that this is a corner column and you have to decide. Okay, so you have to start and you have to analyze what kind of a column it is and you have to design accordingly. Okay, so anyway, there are two moments are there: x direction, y direction. Two moments are there. So from this we can understand this is going to be biaxial bending. Okay. Now, coming to the first one, that is, you have to find out whether it is a short column or a long column. Okay, you have to find out the nature of the column, whether it is a short column or long column. Okay, so short column means what? L effective will be L effective in the least lateral dimension should be less than 12. Okay, so how that is for the braced frames. In case of a braced frames, okay. So that will come as the second criteria of IS code page number 94. So 0.8 into L is 3500 divided by dimension. We have only one dimension. The column is 400 into 400. That is a square column. Okay. So how much you are getting? 0.8 into, tell me the answer first. 0.8 into 3500 divided by 12. I think you'll get 7. So which is less than 12, which means that you are going to design a short column. Okay. Have you got this? We are going to design a short column. Okay. So this column is a short column. Okay. Now, second one is that, see this. So we have to make sure that this column is subjected to biaxial bending. Okay. So not much details are not given, just the building details. They have taken a case from the practical. The practical situation case on it. So we have to confirm that this is a biaxial bending. Okay. So that's the next thing that you have to do. Biaxial bending. We have to confirm that this column is subjected to biaxial bending. Okay. So for that, first of all, you have to find out the eccentricity of the load. Eccentricity of the load. Okay. So moment equation is equal to P into eccentricity. That is, moment is equal to basically what? Force into distance. Okay. Moment means basically that is force into distance. Okay. So if you convert this into our terms, we can say here the force is axial load. D will be eccentricity. See this problem. Okay. So this is the motor. This is here is the moment is that going to develop. Okay. So force will be applied and eccentricity on a distance. Okay. So that is force into eccentricity. Okay. So we know the moment, we know axial load, we know. We can find out the eccentricity. Okay. So come to the first one. Moment along the x direction is equal to load into eccentricity in x direction. So moment along the x direction means how much you are getting? How much is x direction? Mux is equal to, how much it is? Mux is equal to 190 kilonewton, right? So 190 is equal to, so 190 into 10 raised to 6, converting into Newton mm, and the load is 1300 into 10 raised to 3 into E into x. So eccentricity along the x direction is 190 into 10 raised to 6 divided by 1300 into 10 raised to 3. So you will get this around 146.15 mm. Okay. Similarly, along the x direction, eccentricity along the x direction. Okay. So moment along the y direction is 1110 into 10 raised to 6. That is converting into Newton mm divided by axial load 1300 into 10 raised to 3. Okay. So you will get the eccentricity along the y direction as 84.16 mm. Okay. Okay, 84.16 mm. Okay, so this is the eccentricity that is occurring in the column. Okay, that is 146.15, 84.16 mm, which means that if you take this column, okay, for example, if you are taking this column, clearly, okay, if you are taking this column, it means that from the x direction, okay, so this will be this thing, okay, so from the x direction, the load is acting at a distance of 146.15 mm, and from the y direction, load is acting at a distance of 84.16 mm. Okay, somewhat here the load will be acting. Okay, another x direction at a distance of 146.15 and from the y direction at a distance of 84.16. Distance the load is currently acting. Okay, so that much details we have got. Okay, so that's the eccentricity that is occurring in the column as per the moment. Now we have to see how much is the maximum eccentricity as per the IS code. As per the IS 456, how much is the maximum eccentricity, but how much is the minimum eccentricity? Okay, so that is given on the page number 48. Okay, so that is equal to L by 500 plus T by 30. Okay, so that is 3500 divided by 500 plus D D divided by D is the dimension of the column, 400 divided by 30. Okay, so that is equal to, you will get the value of 20.33. Okay, so IS code is telling that minimum you should have a value of 20 mm. Okay, here we have got it as 20.33. So IS code is telling that you can have an eccentricity up to minimum of 20.33. Okay, 20.33, that is the eccentricity value mentioned as per the IS code. But in the real case, how much we got? We got the eccentricity along the x direction as 146.15 mm, and along the y direction we got this as 84.16 mm. Okay, so if the condition is like this, that E minimum is greater as per the IS 456. Okay, E minimum as per the IS 456 is less than the eccentricity that is occurring in the column. We can make sure that the biaxial bending is occurring in the column. Okay, biaxial bending is occurring in the column if the condition is like this. Okay, so in the previous case, they have told that this is a short column, so some details was given. Okay, so that's why we didn't do the steps. Okay, that's the first step, that is whether to make sure this is the short column or not. Okay, second step is to eccentricity. But these two steps we skip there because they have given some details in the question. Here they have not given. Here they have given that it is a braced column, this is a corner column. Okay, so a practical situation in the case of the okay, so in that case you have to make sure that this column is a short column and also this is subjected to biaxial bending. Okay, so this is subjected to, if the so here the condition is like the E minimum as per the IS E minimum is less than eccentricity that is occurring in the column. So it is a clear case of biaxial bending. Okay, now we have to design the column as per the biaxial bending where there is no doubt in that. Okay, so that's it. Now coming to the step number 3. Okay, step number 3, same as previous, there is no difference. First of all, you have to assume, you have to find out P by FCK. So we don't know how much is the P. P is the percentage of reinforcement ratio. So you have to assume the percentage of reinforcement ratio. Okay, so here we can take a P as 3%. Okay, here you can take the P as 3%. Here certain amount of reinforcement is required in the column. Okay, Please, if you take 2% or if you take 1.5%, this will not be safe. The column will be failing under biaxial bending. Here you can try. Okay, you can try. Can go. You can provide P is equal to 2%. You can try. Let's see what is the result. Okay, most cases this will be failing in 2%. Okay, so this here you need a percentage that is 3%. That is, you have to make an assumption. For example, if you're starting with the P is equal to 2%, okay, the 2% will start definitely end of the stapler, the column will be failing. Okay, the biaxial bending it will show that the column is failing in biaxial bending. So immediately you have to redesign the section. Okay, so that means again you have to increase the percentage of reinforcement ratio. Instead of 2, you have to take 3. Okay, so you can try by yourself if you want. For now, you can take it as P is equal to 3%. Okay, P is equal to 3%. So assume P is equal to 3%. So P by FCK. So that's it is equal to 3 by 25. So 3 by 25 is equal to how much? It will be around 0.12. Are you getting this? Okay. You have assumed P as 3%, so P by FCK value is 0.12. Next is you have to find out PU divided by FCK B into D. PU is 1300, that is the axial load acting, divided by FCK is 25. Here B and D is equal. Why? Because it is a square column. Okay, 400 into 400. So how much you are getting? Tell me fast. How much is the answer? P by FCK B into D. Somewhat you will get it as 0.325. Are you getting these answers? 0.325. Are you getting this? Okay. You will get 0.325. Okay. Now, what we have to do? You have to find out mu divided by FCK value. Mu divided by FCK DD square. You have to find out from ST16 chart. So you need to select a chart. To select a chart, you need to know what are parameters. You need to know how much is D dash by D value, then F5 value, and whether you are providing reinforcement on all 4 sides or not. Okay. So anyway, this is a biaxial case. You have to provide reinforcement on all 4 sides. So that one is confirmed. Reinforcement on 4 sides. F5 is 415. Already it is not. Okay. D dash by D we don't know. Okay. So D dash means what? Cover. So D dash is cover. So assume the cover as 40 mm. Assume the cover as 40 mm. So 40 divided by 400. You will get D dash by D as 0.1. Okay. Assume D dash by D. Assume D dash. Okay. I'm erasing it. Okay. So write down. Assume the cover. Assume the cover, that is D dash. Assume the cover D dash as 40 mm. So which means D dash by D is equal to 40 divided by 400, that is 0.1. Okay, so F5 value 415, reinforcement that is provided on all 4 sides. So based on 3 factors, you have to select a chart from ST16. Okay, so take ST16 now. All of you take ST16. Oh God. ST16, it will be chart 44. I take ST16 chart 44. ST16 chart 44 another based on the value, that is based on P by FCK 0.12 and the P by FCK will be B into D. Okay, based on these 2 values, find out the MU divided by FCK BD square. So properly that is going to be chart 44 only. Find out mu divided by FCK BD square value and tell me how much is the value coming. Okay, first we have to complete this problem in this. So now nothing, no full same as previous. Only that 1-2 step is extra. So SC16 chart 44. You can take chart 44. So this is chart 44. So see this, all the criteria is satisfied over here. Okay, so this is chart 44. So here the reinforcement is provided on 4 sides. Okay, so that is satisfied. D dash by D value is 0.1. Fy value is 415. Okay, so all the conditions are satisfied. We can go with chart 44. Okay, now find out mu divided by FCK BD square value. You have to find out. Okay, so P by FCK value is 0.12. Okay, so this is the curve. Okay, this is the curve. So directly here we are having this curve. P is equal to 0.12 curve directly it is here. Okay, you can see. PU divided by FCK value is 0.325. So this is 0.3, 0.4. Okay, so this is having 0.2 division. That is 0.32, 0.34, 0.36, 0.38 and 0.4. Okay, so this is 0.325. So this is 0.3 and this is 0.34. Okay, somewhat over in between here. Extend this line to 0.12 curve. 0.12 curve. So this is 0.12 curve. Okay, so this is 0.12 curve. Okay, ഇപ്പോൾ ഈ ലൈൻ പോയിന്റ് ഈ 0.12 curve പോയി ഇന്റർസെക്ട് ചെയ്യണം. ആ ഇന്റർസെക്ട് ചെയ്യുന്ന പോയിന്റ് താഴത്തേക്ക് ഡ്രോപ്പ് this point. So how much you are getting? mu divided by FCK BD square value, tell me. How much you are getting? Fast. So this is the point. So how much it is? So this is 0.1. So 10 divisions. 0.1, 0.15 and this is 0.2. So how much it will be? So this is coming around 0.15 and 0.16. So how much is the value? Tell me first. How much you are getting? You can take it as 0.152 something like that. Okay, 0.152 something like that you can take. Okay, so the value will be falling under 0.15, 0.152. Okay, so take this. So mu divided by FCK BD square is equal to 0.152. Okay, so from this we have to find out the moment capacity along the x direction and the moment capacity along the y direction. Okay, moment capacity along the x direction and moment capacity along the y direction. Okay, so here how much it is? B is equal to D. This is a square column. Okay, so both mu x1 will be equal to mu y1. The moment capacity along the x direction and moment capacity along the y direction will be equal. Why? Because B is equal to D. This is a square column. The square column. Okay, so here the parameters will be same. Okay, so first we will find out moment capacity along the x direction. That is 0.152 into FCK is 25 into how much? 400 into 400 square. here 0.152 into 25 into 400 square into 400. So anyway, the moment capacity along both directions will be same. Okay, if you are taking 0.15, that is also okay. You can go with 0.15, no problem. Okay, if you want to take 0.15, that is also okay. Okay, so tell me the value, how much you are getting moment along x direction, moment along y direction first. Okay, 243.2 kilonewton meter. Okay, 243.2 kilonewton meter. Both case you will get 243.2 kilonewton meter. Okay, so now that we have got the moment along the x direction and the moment along y direction. Okay, now you have next step. Step number 4. Okay, step number 4. What is step number 4? You have to find out PU set, that is ultimate load carrying capacity of the column. Okay, ultimate load carrying capacity of the column. Okay, so tell me, how will you find out? Again, you have to refer SP16 chart 63. So this is SP16, page number 148, SP16. Chart 63, you have to find out the ultimate load carrying capacity of the column. Okay, so how much is ultimate load carrying capacity? How will you find out? First of all, you have to how much is the reinforcement ratio? Reinforcement ratio is 3. Reinforcement ratio is 3. So take 3. So 3 is directly given over here. Okay, 3 value is directly over here. Okay, so from the 3, draw a line that is coinciding with your grade of steel. So our grade of steel is Fe415. Okay, Fe415 and a grade of steel. Okay, here it has been coincided. Okay, now drop it down till it coincides our grade of concrete. How much is our grade of concrete? Our grade of concrete is M25. It is not M20, it is M20. M25. Okay, so drop it down. If you drop this line till it meets M25. Okay, now extend this line to the x value. Okay, so here it will be going to x value like this. You can use a scale to find out all these values. So this is your PU divided by AG value from the class. So how much you are getting PU divided by AG value? Tell me fast. So it will be somewhat below 20. Okay, like something like so this is each one is having one division, 21, 22, 23, 24, 25. Okay, somewhere here like between 20 and 21 you will get a value. How much it is? 21. Are you getting 21 exactly? Between 20 and 21 the value should come. Just do it once again. Something like 20.5 you will get. Okay, 20.5. Okay, so this is 21, 20. This is not 21 is 21.5, 20.5. Okay, 20.5. So take 20.5 PU divided by AG value. So PU set divided by AG from the SP16 graph, we got this as 20.5, and PU set ultimate load carrying capacity 20.5 into area of gross section, that is 400 into 400. So how much is the value? Tell me. PU set into 20 into 20. So that will be around 32800. Okay, that is right. So that will be 328 kilonewton, right? 328 kilonewton. Okay, so to use that value, you got it as 328 kilonewton. So next is PU divided by PU Z ratio. How much is PU divided by PU Z ratio? PU is 1300 divided by PU Z is how much? 3280 it will come, right? 3280. Okay, 3280 kilonewton. 3280. So how much is the value? Okay, so 10. The value 1300 divided by 13. So somewhat 0.4 something, 0.4 or 0.3 something you will get value. How much is the value? Tell fast. PU divided by P set 0.396. Okay, 0.396. So PU divided by PU ratio is 0.396. Okay. So next step is you have to find out the permissible value of MUX divided by MUX1 permissible. That is from IS. So that is from SPA 16 chart 64. You can take it as a homework. Okay. Same like we have done in the previous problem. Okay, so based on this PU by PZ ratio and based on MU divided by MU1 value, you will get a value, permissible value. This MUX divided by MUX1 from chart 64. You can take it as a homework. Okay. Next, most important step, that is step for biaxial bending. Okay, so this step you have to do. This step കഴിഞ്ഞാലാണ് നമുക്ക് കൺഫേം ചെയ്യാൻ പറ്റുക നമ്മുടെ column safe ആണോ അല്ലയോ എന്നുള്ളത്. Okay, check for biaxial bending. This is very important step. So MUX divided by MUX1 alpha raised to n plus MUY divided by MUY1 all raised to alpha n should be less than 1. Okay, so alpha n value you will get it from so either we can go for IS 456 page number 71 or in SP 16 it is given, the chart is given. Okay, you can refer any value same. Okay, so alpha n value depends upon PU divided by PZ ratio. How much it is? PU value 0.2 ആണെന്നുണ്ടെങ്കിൽ if PU divided by PZ value, if it is 0.2, the value 0.2 നേക്കാളും ചെറുതാണെങ്കിൽ alpha n 1 ആക്കി എടുക്കുക. And if it is greater than 0.8 നേക്കാളും വലുതാണെങ്കിൽ 2 എടുക്കുക. 0.2ന്റെയും 0.8ന്റെയും നടുക്കാണ് വാല്യൂ വരുന്നുണ്ടെങ്കിൽ interpolate and find out the alpha n value. Okay, so here the PU by PZ value you got it as 0.396. So approximately we can take it as 0.4. Okay, the 0.396 PU divided by PUZ value you got it as 0.396. that is round it and make it to 3.4. Find out this value, alpha n value, how much you are getting. So this you will get it as 1.8. Okay, this you will get it as 1.8. Interpolate and find out, you will get it as 1.8. Okay, now check MU divided by MUX1. So MUX, how much it is MUX? MUX is 190 kilonewton divided by MUX. How much is MUX? 243.2 all raised to 1.8 plus 1110 divided by 243.2 all raised to 1.8. Tell me whether this is less than 1 or not. If it is not less than 1, you have to redesign the section. If it is less than 1, it means that this is safe in biaxial bending. You can proceed the design. Okay. So just like previous തന്നെ രണ്ട് സ്റ്റെപ്പിന്റെ വ്യത്യാസമേ വന്നിട്ടുള്ളൂ. ഓക്കെ, അതുകൊണ്ടാണ് ഇത് കുറച്ച് ഫാസ്റ്റ് ആയിട്ട് പോയത്. So all of you do this problem and tell me whether are you getting this value less than 1 or not. Okay, now you can post your name to mark the attendance. You can complete this problem as a homework. Okay, do this problem as a homework. Tell me whether it is less than 1 or not, and after that do the reinforcement ratio.